Day 2 of 1.1, we are talking piecewise functions. You probably have had an intro to piecewise functions. What warrants getting the name piecewise function? It is just a function that is put together two or more equations. I would say the vast majority of the ones we will ever see will be three functions, three equations. Sometimes two, every once in a blue moon up to four. That's not a rule. We just usually see three of them put together. If you already know what a piecewise function is, you probably don't need to really write that down for yourself because you already know what they are. They start with this f of x. It doesn't have to be the letter f. It's just a function notation at the beginning, g of x, h of x, something of x, and then equals, and then everything grouped together with this curly bracket is what's going to be included in that function. And what you'll notice following that is an equation of some sort, and it's going to actually look like an expression of some sort, followed by, and it doesn't have to be a parenthesis or a comma, it could just be a space or the word if, and then it will be some sort of an inequality, clarifying when you use that equation. X is greater than 5. 2 is less than x is less than 7. It tells you when you will use that particular part of the function. Today we're going to look at evaluating them. So at the beginning of class today in our warm-up, it's called evaluating. We were plugging in values to our function. That's all we're doing today is plugging in values to our function. But when it's a piecewise, you have to pay attention to which function or which part of the function. So here's one example. It says find f of -2, f of 3, and f of 10 for the piecewise function. And then it gives us this, and I'm going to zoom in so you can see that a little bit better there. Here's our function, f of x equals, and then it gives us three expressions. -4x plus 3 if x is less than 3. Negative x cubed if 3 is less than or equal to x is less than or equal to 8. And 3x squared plus 1 if x is greater than 8. When you evaluate a piecewise function, you're really going to start at the end of the function and kind of work your way backwards. And why I say that is our first one says we're supposed to evaluate f of -2. This is my x. That's what I'm looking at. And so I go to the end of the function where it says the clarifications for when I use each function by the x values, the inequalities for x, and I see which one it works in, -2. So my options are -2 is less than 3, -2 is between 3 and 8, or -2 is bigger than 8. Okay? Well, it will only ever work in one of those. -2 is less than 3, right? So this one would work in that first equation. And all that is telling me is, of those three options, which one I'm actually going to plug -2 into. And because it works in the first inequality, I use the first expression. And I just come and plug -2 into that expression. -4x, which I replaced with -2, plus 3. -4 times -2 is 8. Plus 3 is 11. We get 11. Questions? Okay. And we repeat the process for however many times they ask us that. So the next one, f of 10. Again, I come over here. Is 10 less than 3? No. Is 10 between 3 and 8? No. Is 10 bigger than 8? Yes. And since it works in that last inequality, I use the last equation to plug 10 into. While we are doing this, I don't have a calculator in my hand, so I'm going to do this by brain power, which means I got to remember my order of operations. Please excuse my dear Aunt Sally, PEMDAS, however you remember that, PEMDAS, right? Order of operations, parentheses, exponent. Exponent is actually the first thing we should do here. 10 squared is 100. Then multiplication, right? Times 3 is 300 plus 1, 301. Reason I point that out is it's actually pretty common that people would multiply that together first and then square it because that's the order it's written, right? Well, 30 squared and 10 squared are very different numbers. So, any questions on that one? Okay, last one, f of 3. Now, this one I want to point out because this is probably going to happen on almost every piecewise question that we are handed. And that is they are going to ask us about one of the numbers where we switch between equations up there. And what do I mean by that? Do you see how 3 shows up on 2 different lines up here? Okay. They're going to ask you one of those where it shows up on multiple lines because it forces you to slow down and say, okay, which one does that actually work in? So if my number is 3 less than 3? No. Is 3 greater than or equal to 3? Or equal to is the key, isn't it? We're looking for the one where it says or equal to. And they will almost always ask you one of those where it switches between equations. Because it is or equal to, we would use that middle equation. And then my second reason I want to talk about this one is the whole negative thing in front. Now, it doesn't actually change our problem much here, but it does say negative x cubed is the equation I'm using right now, right? That's the expression I'm using to plug in 3. When it's the negative out front, I then put in my number and my exponent. Well, the reason that clarification is important is I do the exponent first. The negative's like a -1. I do that second. So it'd be 3 cubed, and then I tack the negative on my answer. Okay, so 3 cubed is 27. Put the negative on it, it's -27. Now, because it's a cube, that wouldn't have changed our answer. But if I made that like a squared, it would have if I did the ordered backwards. So just be cautious with the negatives already there. Any questions on our piecewise functions? All right. Next one. Wow, that's a lot of words at the top, isn't it? It's just this explaining this function to us. And it's saying average max height of children in inches as a function of their parents' max height in inches can be modeled by the following piecewise function. Find the average maximum height of children whose parents have the given maximum heights. Use h of x where x is the independent variable. That's a lot of stuff. It's just explaining what this is. It's basically saying if this is the parent's height, this function estimates for us what the kid's height could be. Okay, so that kind of gives you just a frame of reference for does the answer seem appropriate. If I plugged it in and got a height of like 4 inches, probably not the right answer because not a lot of people walk around in this world 4 inches tall, right? So gives us a little bit of frame of reference for our answer. But what I want you to do right now is with your table, decide which of those you would plug it into and find your answer. I'll give you a few minutes to do that. All right, let's go ahead and check our answers here. Let's go with Ellie Goebel. On the h of 67, did you pick the first, second, or third equation? The second equation. Jude, what did you guys give for an answer then? 70. Very good. Seem appropriate? A little bit taller than their parents? I think that seems good. Let's go with Brogan on the second one, h of 72, first, second, or third equation? Third equation, I agree. And how about Nick Wageman? Answer. 78. Very good. Questions? All right. One more to try here. Decide which one you're going to plug it into and what answers you get. All right, let's go ahead and get some answers up here. Let's go with Dylan on f of -2. Did you pick the first, second, or third equation? First one. Sydney, what do we get? -2, right? We're plugging it into the first equation. First equation is x, which means it doesn't change my answer. Okay, next one, let's go Cole Gideon. F of 8, did you pick first, second, or third equation? Third equation. Lily, what do you get? 64, agreed. Okay, and our last one, let's go with Sailor, first, second, or third equation? Second equation? Changing your mind? Which one would you like to change it to? 3. Is 3 less than 0, between 0 and 3, or greater than or equal to 3? Greater than or equal to. So we should go with our third equation, which then, Seth, makes our answer 9. So with that being said, this is kind of why I picked this example. We used first equation, third, third. Did we ever use a second? No. Do we need to use all the equations every time we do this? No. You could use the exact same equation for all 3 of them if that's the number they asked you to evaluate for. There is no rhyme or reason to it. It doesn't go first one with the first equation, second with the second, or anything like that. So you'd have to pay attention to what number they're actually handing you and where it fits, because we could use the same equation every time. Okay? All right, last thing that I want to show you today is this. Yesterday, we talked about, is something a function or not a function? We looked at some pictures of graphs, and we learned about this thing called the vertical line test. So, quick recap on vertical line test. We drew vertical lines through our picture, and if we hit the graph at more than one point, it wasn't a function. All of the functions, we would only hit it at one point if we were to draw those vertical lines in. We did not see a picture like this first one that's got this shading up here. And so if I draw my vertical lines in here, well, first of all, let's rewind. Before I draw that vertical line in there, do you guys remember what type of expression gives me something with shading? An inequality. Am I hitting my inequality at more than one point if I draw a vertical line? Yes, I am actually. Most of us, obviously, eyes go right to the line, but in an inequality, didn't the shading represent all of the possible answers that could work for that inequality? So aren't all of these also answers, which means I'm hitting it like a bazillion times or more, right? So that is just to show you that inequalities, because they have shading, will not be functions, right? The shading automatically makes us lose that vertical line test. The second one, now we actually talked about this in class yesterday as well, but remember on piecewise, we need to be cautious where they overlap. You don't see this very often, but does that pass our vertical line test? No. You got to pay attention to the open and the closed. If those are both closed, it's hitting our function in 2 places with this one vertical line. The one we saw yesterday, that was an open dot, wasn't it? And that's what allowed it to pass the vertical line test. They either need to both be open or one of them needs to be open. If both of them are closed, it's going to fail that vertical line test. Questions? All right. At this time, will you guys get out your Chromebooks? We do have a homework quiz that we are going to take. Your assignment is going to be on the board when you are done with that homework quiz, and we will talk here in just a second about that.